I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
Hi, welcome back to the part 2 of the mystery of the crackling radio. I cleaned the, if you recall last time, we had this mysterious crackling that comes and goes. Right now it's being pretty steady. Sounds like this. And so I have the chassis upside down on my high-tech yogurt container. I'm sure you all use the same technology I do. And we have the oscilloscope set up right here at the top of C6. It's a mica cap, but part of the AVC circuit. And my speculation last time was that there may be some noise on the AVC line inducing the noise that we could see in the grid of the 75 tube. So let's look and see. I mean, we're getting plenty of crackling right now. So let me set this up so you can see the scope. All right, what we're looking at is, as I said, there should be a negative voltage on there. This is ground on this probe. We're set to half a volt per division. So we have, if we go switch to DC, we have minus 0.7, 700 millivolts, negative bias. There is no station being tuned in right now, so the AVC is very steady. And as you can see, no evidence of noise. Let me switch to AC so we can improve the look at our smaller scale, and there's some, AC hum in essence on there, and some crackling. Yeah, so you can see it right there. But it's very periodic, which is kind of surprising, or interesting. I don't know if it's surprising, but it's interesting. So, what have I found underneath? Well, first of all, let's look at some other sources of signal in the circuit. Let's go back to the grid of the 75 tube and see what it's doing. Okay, looking into the belly of the beast, the 75 tube is right here, and I said let's look at the grid, and it's still 1, 2, but I decided to look at the plate first of all and see that noise being propagated. Where is that? There it is. So right here is where we were just looking, and there was a little bit of noise on there. And we had looked last video right here at the grid of the 75, and I thought, I changed my mind just as I said we were going to look at the grid, and I put the scope probe on the plate, which is right here. And as soon as the scope probe hit it, no sparks or anything, it's that the crackling stopped, just completely stopped. So now I have to wait for symptoms again. But why would that change? What would the probe, laying the probe on there, change? Well, it would change not very much. This is a 250K resistor, so it wouldn't change that resistance. One side of the probe is connected to this ground. It would change the capacitance of the C9 capacitor, which is a 25 microfarad, 25 nanofarad capacitor, which is right here, I think. It says mica. It says right there. And there are two of these micas in here. And this one reads, as I test in circuit with my little meter, this one reads pretty close to what it should be, which was, oh, what was it? Yeah, it's supposed to be 25 nanofarads, and it was 18. This one, on the other hand, which is this C9, as I recall, yes, this C9 right there is way off in circuit. So I think what I'll do now is I will heat up my soldering iron, lift one side of this mica out. I mean, these don't fail very often, granted, but occasionally they'll have heat fatigue or a crack or something. So I will lift one end of this out and see if it's close to what it should be, and then we'll go from there. All right, here we are. In that last segment, I misidentified those two capacitors, got them turned around. Where'd it go? C6 is the AVC one, and that's right there. And C9 is the one off the 75 tube, and that's right there. But they're both the same value. They should both be exactly the same. So I've got my little ASR meter set up. We'll take a look at the one hanging off the 75 tube first. And it says it's 223 picofarads, which is supposed to be 250, but 223 is undoubtedly close enough. So let me get on to the other one. All right, here's the other one. And 251, so can't be any closer. So the likelihood of it being one of the micas is pretty slim, I think. And what I think at this point is the act of my putting the probe on this plate of the 75 tube changed the connection. So it's probably bad solder. A bad solder joint here. So I'll clean all the solder out of here. I'll rewrap the wires around the tube post and resolder that. I'll do the same to this guy over here, and we'll see what happens then. You might recall that I was speculating that one of the potential things that could be going wrong with this is a loose solder connection. So as I said, the crackling comes and goes. This 60 hertz hum that I heard was kind of coming and going too, or raising anyway. So I was just wiggling the wires in the, this is the speaker harness that goes to the socket right here. And I was wiggling the wire, and then I realized that I could see the center wire right there. I don't know if this is showing up on camera or not, but the center wire right there is moving up and down. In other words, there's no solder in this socket hole. Now why that is, I don't know. Probably, no, I did not change these wires. So I don't know why it was not soldered. More importantly, I don't know why I didn't notice it before. So let me get that soldered up and see if that makes any difference. We'll see. Well, I've had it running for some hours. I'll turn it back on. And it hasn't crackled once. So at this point, I'm presuming that it was that cold solder joint inside the speaker plug. It's interesting. Anyway, it's back in its original situation. I've got the Bluetooth module hooked up, and it's I'm streaming my favorite radio station in the Northwest, KBRD, and you can get their stream at kbrd.org and send them $1 or $2 because they play old music. And some of it's, pretty rough quality, but it's splatters from the 20s and 30s. Plus some newer stuff too. Anyway, the radio seems to be working fine. I even to prove to myself that it was okay, hooked a wire up to the crude AM antenna coil, and it even picks up our local radio stations, but I don't care to listen to them, so anyway, it's done. I'll put it back in the case and call it a day and start on the next project. So yeah. Well, there we are. It's all back together, playing well, no crackling. It actually improved the volume quite a bit, and when I repaired that socket, it looked to me like it had a cold solder joint from the very beginning, from original manufacturing. May or may not be true, but it's a good solder joint now. So, that's it. Thanks very much. See you next time. Be safe.